So firstly, let's open up Google Colab to view what we have done. Firstly, to do our work, and we imported several libraries on Google Colab. Therefore, for me, in my case, it was NumPy, Pandas, and Matplotlib that we have used for graphics. And the second, we connect our Google Colab to our Google Drive, and we already have imported our Google CSV dataset that we have installed from Google to our Google Drive. Then we connected using Pandas library. As we can see, my dataset contains a lot of information. That is mostly we do the data distribution for each column that we have in our data set. For this, we already have installed Pyplot, Seaborn, and Pandas libraries. So in this, first we have numeric columns and have string columns. So one of them, that's for distribution for names, and distribution of age. Mobile using is mostly, in my data set, there was mostly people, students that age 21 to 25, and based on gender, and distribution of mobile phone, do they have or no, and distribution of mobile operating system, do they use Android or iOS system, and distribution of mobile use phone, if they use it frequently or rarely or never use for studying, and what do they do, and I mean what activities mobile phone. And not only we can use we can also use machine learning techniques like decision tree, random forest, logistical linear regression for our dataset. And then the first one I used for decision tree for health rating prediction of my dataset. And the secondly, it's the correlation matrix, but I did the other one that I have already shown you, because this one is a bit messy, and that's why I skipped. But it includes all the columns, and after I converted all the column data to numeric data, I could do correlation matrix. But before that, it was more difficult. And this correlation matrix is overall matrix. And then linear regression wasn't as good as with others, because the first thing is my data set is not that numeric. It doesn't have that much numeric data other than the health rating, daily usage, or age. So they don't have that much of a linear regression between them. And you can see that's the linear regression that they have, best fit line of the regression. And for predict how health rating will be after 10 hours of daily mobile usage, we could use linear regression, and the result was the health rating would be 3.45. And as you can see, it's Android, the prediction. Next thing is SimSport. First, we open our Google Colab, and as we can see, we have we have so many libraries for using SimSport. And firstly, of course, we will connect our database dataset to our Google Drive and our Google Colab too. And as you can see my dataset, and then we use access token and the URL of our SimSport device, and we put it here. Then we show what columns it should use in our dataset using for index row. And yeah, as you can see, I didn't use demo version of SimSport because I already have started 1 month free trial of SimSport for me, and because my dataset doesn't have that much of a numeric value, it wasn't that good. That's the device that I have opened. And in the dashboard, we can see that we can add widgets. I don't have time-related data, that's why my graphic wouldn't look that good. Let's choose any daily usage, or let's use house rating. It doesn't work.
The data that I have chosen from Google was impact of mobile phone for students' life and for their academic performance. Mobile phones are integral to modern day life, especially among students who rely on them for communication, education, and entertainment. However, excess mobile phone usage has raised concerns about its impact on health, particularly sleep quality, stress levels, and physical activity. Understanding this relationship is crucial to mitigating adverse health effects and promoting healthier habits. Our dataset provides a comprehensive framework for studying these interactions and includes 500 rows and 10 columns capturing data on mobile phone screen time, academic performance, physical activity, sleep quality, and self-reported stress levels. Data gathering was the first step in creating the analytics platform that we have installed from Kaggle. Numerous attributes that we use for analysis and prediction may be included in this data. And we examined the dataset during data analysis in order to find trends, patterns, and insights that could direct further steps. The first, we have flowchart of our work. First, data collection, data gathering, as we have said, and we have the data process, handle missing values, handling duplicate values, and so on and so forth, and descriptive analysis to do analysis for charts or machine learning techniques. And then we use model selections that we have models, decision tree, linear regression, logistic regression, or like random forest, and training, testing them, and the visualization of them, and then deployment of analytics platform. And the case study is about the impact of mobile use for students' life, and therefore the two graphs show how healthy health rating of students depends on and how internet distracts students. As we can see, first is how the health rating is defined based on the daily usage of mobile phone, and the second, how using the mobile phone distracts them from from studying exams, or not just studying at all, and or during the class lectures. And the model selection, we have chosen two model machine learning techniques. First, linear regression is a statistical method used to model the relationship between a dependent variable and one or more dependent variables by fitting a linear equation of observed data. The second, random forest, is an ensemble learning algorithm that builds multiple decision trees during training. To do a descriptive analysis, we used Google Colab as well. As you can see, I chose the numeric data of my dataset, and therefore they are daily usage and age and health rating, not health rating. And as you can see, it summarizes key statistics for daily usage, age, and health rating. On average, participants spend about 4.7 hours daily, with most falling in the 4 and 6 hour range, and a few outliers using significantly more or less. And the average age is 23, with most participants in 21 to 25 age group. And health ratings average around good to excellent, with the majority of their health positively, and while a small number rate was fair and poor. Correlation metrics. The diagonal elements have value of 0, as each variable is perfectly correlated with itself, and of diagonal value represents the correlation between performance, impact, and health rating is 0.05 minus 0.05. This value is very close to 0, indicating an extremely weak negative correlation. In practical terms, this means there is almost no linear relationship between the two variables. And the decision tree graph, that it shows how the model makes prediction. The top root node is the first decision based on important feature, like daily mobile usage. As you move down, each node represents a further decision based on other features. The leaves at the bottom show the final health rating prediction. And lastly, we have SingSport. One is inefficient because my dataset doesn't contain time or date data. It's only about how much people spend, how good about their health is, or something more, and that's why it doesn't show in a chart. And also, I wanted to know that my dataset is not really numeric dataset. To use machine learning techniques in my data, I had to convert everything to numeric data. So in case of SingSport, it was much more difficult. But as all I could do in my SingSport is this. And the study underscores the significant impact of mobile phone usage on students' health, highlighting the relationship between screen time, sleep quality, stress levels, and overall well-being. Descriptive analysis revealed that excessive mobile phone use is strongly correlated with poor sleep quality and higher stress levels. And the machine learning models like linear regression demonstrate its ability to predict health outcomes with impressive accuracy. And those findings emphasize the need for balanced mobile phone usage, particularly among students, to mitigate adverse health effects.